Hey guys, Mr. Jenkins here. Hopefully, if you are watching this early, you've had a good day on a Friday, and hopefully, if not, then you're having an all right day here on this Monday. So remember that you just took a quiz over 5-1, 5-3, and 5-4, right? So now 5-5 would come next. And this would be our third and kind of final form of a linear equation called standard form. So what do we want to be able to do? We want to be able to write and graph linear equations using standard form. All right, so first of all, what standard form look like? So it looks like this. Standard form is something times x plus something times y equals your constant. So in other words, x and y are on the same side. So really, standard form kind of just looks like a DMR problem, right? I could give you something like this and say solve for y. Okay, so that's kind of what we're looking at. Our vocabulary terms that are new from this lesson, x-intercept and standard form, which I just talked about standard form. If you know what a y-intercept is, then an x-intercept is probably, pretty obvious what that is, right? Y-intercept is always in the form 0, b. X-intercept would always be in the form some number, we'll call it x, 0. Okay? It's where the line touches the x-axis. All right, so that is what standard form is all about, finding the intercepts. Okay, so I'm going to show you the math teacher way to talk about it, and then I'm going to show you the really easy way to come up with those intercepts. All right, so if we go one by one, let's just go x-intercept first here. What you do is you plug 0 in for the other variable, right? So in this equation, that'd be 3 times x plus 4 times 0 equals 24. Now, eventually, you shouldn't have to show all that work because every time you plug in 0, it essentially just makes that term disappear, right? So what we're left with is 3x equals 24, which gives me that x equals 24 over 3, which is 8. Okay, so my x-intercept is 8, or I prefer to say it's the point 8, 0. Okay, the y-intercept, well, you know one way you could find the y-intercept. You could solve for y and see what your constant is. That would be a way. But with this, the idea is you want to leave it in standard form to be able to find the intercept. So we're going to repeat that same process we just did, but we're going to plug in 0 for x. So that'd be 3 times 0, just going to my original equation, plus 4 times y equals 24. That makes that just go away. So we have 4y equals 24. And that gives me y equals 24 over 4 is 6. Okay, so my y-intercept is y equals 6, or I prefer for you to think of that as the point 0, 6. All right, so like I said, that's kind of the math teacher way to show it. Here's how your thought process needs to go. I'll leave B for you. Let's go ahead and look at C. All right, C, the numbers aren't great. Actually, let's maybe think of this with some better numbers. So I'm just going to put a multiple of 3 over here. Let's just put 9 over there. So I'm changing the problem a little bit. All right, so to get my set, we'll just go in the order they're listed. You can almost do this in your head, right? So to get my x-intercept, I'm just going to basically, I know I'm going to plug in 0 there. So I imagine that just goes away. So I have that equation, negative 3x equals 9. And really, eventually, you shouldn't even need to show this step. So that gives us x equals negative 3, because 9 over negative 3 is negative 3. So my x-intercept is negative 3, 0. Right? And then my y-intercept, all I'm going to do differently there is sub in 0 for x, which just disappears it. So then I have 3y equals 9, which tells me that y equals 3, which tells me that my y-intercept is 0, 3. All right, so you know what most people will do when I give you this equation on a test is you'll solve this equation for y and then you'll graph it using slope-intercept form. You're doing more work than you need to do there if you do that, because finding the intercept should be the easiest way to graph these. So on that note, let's graph a couple. All right, so we're going to graph using the intercepts. All right, if these equations are in standard form, you would want to graph using the, I'm just going to say INTs for intercepts. All right, so my x-intercept is going to be at x equals -2. Look at that. Don't even need to divide. They just give it right to me as long as I know what to look at, right? So that is -2, 0. The reason I like to write it out as an ordered pair is because a lot of people would find that and then plot it right there, right? That's 0, -2. -2, 0 goes right here. It's the x-intercept. It goes on the x-axis, okay? And we do the same thing to get the y-intercept, right? So if I plug in 0 or disappear the x, then I'm left with -2y equals -2. So my y-intercept, I'm using the equation -2y equals -2. And obviously, you don't have to scribble it out like I'm doing, right? You should just be able to see it. Okay, see it in the equation. So that gives me y equals 1 because -2 over -2 is 1. So this line also goes through 0, 1. Or right there. Okay, and really that's all you need to be able to graph a line. If you want another guide point, just look at your slope. It's 1/2, so you could just go again 1/2, and then you have a third point. But if it's on MathXL or something, all you need is those 2 points. All right. So I'll do one more like that, and then maybe a word problem or two. So I'm gonna leave. I'm gonna go ahead and do B. I'm not gonna scribble it out this time. I'm just gonna hope that you see what I see when I see this. Okay. So my first thought is gonna be I'm gonna find the x-intercept. So I know in my mind I'm gonna zero out the y, right? So I'm left with x equals -3. And then I remember this is the x-intercept, so that's -3, 0 on my graph. Right, and I do the same thing for the y-intercept. All right, I want you to go ahead and name the y-intercept. All right, so hopefully you came up with, you zeroed out the x, so you get y equals -3. So that's going to be the point 0, -3. All right, and there you go. You've got enough there. Any 2 points is enough to draw a line through. I'm going to go ahead and draw my line. Okay, and then I'm just going to finish with arrows, show that it goes on forever. I'm going to leave this one for you guys. Leave C for you all. Looking at, and we've seen these in other lessons, but just a good review, graphing horizontal and vertical lines. So thinking in terms of intercepts is what helps me to remember, oh, is x equals a number, is that vertical or horizontal? So if I see x equals 3, I think of that means in terms of intercepts, that means 3, 0, right? So I go there on my graph where x equals 3, and then that helps me to remember, oh yeah, only a vertical line there would make sense, right? It wouldn't make sense for me to just trace the x-axis. It's just a straight up and down line through that point. Okay, so y equals -4. We think of that as 0, -4 would be my y-intercept. And so that reminds me, oh yeah, that's a horizontal line if it says y equals a number. Okay, ultimately you just have to remember it. Other good stuff to think about is like, what's the slope of that line and what's the slope of that line. All right, so then transforming into standard form. I wouldn't worry a whole lot about these. I'll show 1 or 2 of them, but this is not a main kind of topic. So let me just do A and B real quick, but I wouldn't be super concerned with these. Okay, so really the key on these is that you can't have a fraction, so that's what's going to throw you off. So to get rid of my fraction here, I'm gonna go ahead and multiply by 7. All right, doesn't matter if you do 7 or -7, but you got to get rid of that denominator. So I'm gonna multiply both sides of my equation by 7. Okay, and again, these aren't super important, so if you don't get this, it's not the end of the world. You get 7y equals 7 times -3/7 would be -3, so -3x. And then, sorry, plus 35, because 7 times 5 is 35. Then we just want to move this term over, the x term over to that side. So if it's -3x over here, it's plus 3x over there. So you could say 7y plus 3x. Or vice versa, 3x plus 7y equals 35. Okay, so that's kind of tough, but nothing really super important as far as what you're going to be tested on. Let's look at B, and hopefully, well, I'm going to go ahead and ask you, what form is the equation of B in? It says y plus 3 equals 4 times the quantity x minus 1. What form of an equation is that? All right, hopefully you came up with point slope form. Okay, now let's talk about what the problem's asking us to do, which is to write it in standard form. Okay, so this is going to be similar to writing this in slope intercept form, which we've worked a lot on in all the classes. You're going to first distribute on the right side. So that give me y plus 3 equals 4 times x, and then 4 times -1 is -4. Give my board just a second to get caught up there, and then we want to do I'm going to do kind of a double move just to save some space. I'm going to move the constant over there. Okay, so I'm going to do -3 kind of to both sides to make that happen. And I'm also going to move this term over there. I'll do that in a different color. So that's -4x to both sides. So what I'm left with after it's all said and done would be -4x plus 1y equals whatever -4 minus 3 is. So that'd be -7. All right, so that's the idea, and those are tough, but it's good review, so that's why I showed them. The last kind of problem you'll be asked to do, and this is where this type of equation really is helpful, is in these real world kind of problems. So I'd say this is the most kind of maybe important example for this type of equation. So it says a store sells t-shirts for $12 and sweatshirts for $15 each. So it's a t-shirts $12 each, sweatshirts $15 each. If you plan to spend $120 on t-shirts and sweatshirts, so that's a combination, write and graph an equation that represents this situation. What are three combinations of t-shirts and sweatshirts that you can buy for $120? All right, so since this axis you can't really see is labeled x, and this axis is labeled y, which is normal, we're going to use the variables x and y. And then you just pick, right? So my two variables here are number of t-shirts I could buy and number of sweat shirts I could buy. So you just pick one or the other. All right, so we're gonna let X equal the number of t-shirts. I'm just gonna put T's. And then sorry, that's really sloppy. This board just is a struggle to have it keep up. Try to make that a little cleaner. So X was going to equal the number of t-shirts. So number of T's. And then so Y would have to be the number of sweatshirts. And I put just number of sweats. Obviously, we usually think of sweatpants, but just kind of shortening it. You could set this up as you could flip the variables, right? And our graph would look a little bit different if you did that. All right, so if I make X the number of t-shirts and it's $12 per t-shirt, then the expression for how much money I spend depending on how many shirts I buy is going to be, I wrote 12T. I'm going to write that as 12X. So 12X. Then you could probably guess that next term is going to be plus 15Y. So that's my expression for any number of t-shirts and sweatshirts I buy. And then we want to set that equal to 120, which is the money we want to spend. All right, so let's graph it. We're going to go ahead and use the intercepts, right? So my x-intercept is, you tell me. All right, so hopefully what you came up with is you zero out the y term, so you get 12x equals 120, and x equals 10. So that would be the point on our graph, 10, 0. Which it doesn't go all the way to 10, but that'd be about right there. We'll just guesstimate on that. All right, and then my y-intercept. Go ahead and just work through that one. We zero out the x term, so we're left with 15, y equal 120. And so y is equal to 120 over 15. That would be 6. Make sure that's right. Oh, sorry, 8. All right, so that's why we use the calculator. And then that goes to 0, 8. Okay, so based on those, then if we want to find a third point, which might not be a bad idea, just because we get a little sloppy with our lines, I'm going to think about the slope here. So we can put another kind of guide point. So I go down 8 and over 10. That's my slope, which reduces to -4/5. So I'm going to split the difference there by going down 1, 2, 3, 4 and right 1, 2, 3, 4, 5. And it looks like I did just split the difference there. Okay. I'm going to let my computer get a little caught up. So there's my other guide point, and now I'm going to just draw my line segment. If it's in a first quadrant graph like this, you're not going to draw your arrowheads because we can't have negative shirts or negative dollars or anything like that. Okay. So my 3 combos are represented in these ordered pairs. Okay. Just to save time on the video, I'm not going to write it out. It is written out on the notes. But this combination right here, 0, 8 would be 0 t-shirts with 8 sweatshirts. 5, 4 would be 5 tees, 4 sweatshirts. And then you could buy 10 t-shirts and no sweatshirts. That's what all 3 of those combinations would mean. All right, so that is that lesson. And again, I encourage you, if you see a nice equation in standard form, ax plus by equals c, hopefully you're comfortable enough to graph it using just the intercepts. In other words, you don't feel like you need to solve for y every time. And if you do need to solve for y, then it's nice to have a backup plan anyways. All right, so thanks and have a good one. We're almost to Thanksgiving break.